The topic is solving modulus inequalities. So we can understand this. We can start this topic with the help of an example. Uh, if modulus of x is less than 2, so the right hand side is a number and the left hand side is containing modulus of x. So which what are the numbers which can satisfy this inequality? So I can draw a number line. I can write -2 and 2 because the number is 2, and for because of the modulus, I'm writing -2 and 2. So the numbers in the middle part of this number line from my greater than -2 and less than 2 are will satisfy this inequality. So you can verify, choose numbers. It can be 1, 2, 1 and 1.5. Numbers can be -1, -1.5. So all the numbers here are satisfying this inequality. You can verify 1.5. If x is 1.5, yes, 1.5 modulus is 1.5, which is less than 2. This is true. Again, if you check -1.5, -1.5 modulus here in this inequality, is it less than 2? Just verify. Yes, this is less than 2. Again, true. So all the numbers here are satisfying this inequality. So I can write that if modulus of x is less than 2, this implies that x is greater than -2 and less than 2. So the numbers coming here in the left and the right part of this inequality will not satisfy this in this inequality. This was simple example. Again, I can, this is first, and the second example can be like if modulus of x is greater than 2. So again, number line 2 and -2, check these two parts. So the numbers here can be 3, 4, and 5, so on. Numbers can be -3, -5, -6, so on. So verify -6 here. So -6 modulus in the second is greater than 2. Modulus 6 is greater than 2, which is obviously a true thing. So 6 is greater than 2. And also, so this is okay. And if you take a number, say 5, 5 is greater than 2. Yes, 5 is greater than 2. If you remove the modulus, again true. So here are the numbers which can satisfy this second case. So this implies, so extreme left is x is less than -2, or the right is x is greater than 2. So these are two basic examples for the modulus inequality. So I can write next the uh, two important results based on these two examples. If modulus of x is less than a, where a is a positive number, then this implies x is greater than -a and less than a. And if x is greater than -a, less than a, so and vice versa. If modulus of x is greater than a, then either x is less than -a, the second example, or x is greater than a. These are two important results. Keep in mind these important results, the two cases, one is less than and the other is greater than. This was less than. For the lesson, keep in mind this pattern, and this inequality is greater than. For greater than, either left or the right. If you have -a and a here, so this is the case for greater than, and if -a and a here, so the middle part. So with the help of example, we can understand this again. So question is, solve the inequality 2x minus 5 is less than 3. So this is less. For the less, we keep x in between 2x minus 5 and two inequalities open towards right. Write minus 3 here, write 3 here, and then you can split into inequalities or you can do it directly. Minus 3 plus 5 is less than 2x is less than 5 plus 3. Then 2 is less than 2x is less than 8. You can divide by 2, divide by 2, and divide by 2. So we have 1 is less than x less than 4. So the numbers from minus 1 to 4. So this is the answer to this inequality. So if we take any number from 1 to 4, from greater than 1 and less than 4, any number will satisfy this given inequality. So the solution of this inequality is here. X is greater than 1 and less than 4. This was first example, and you can call this first thing as type 1. So yes, this is type 1 of the inequality. There are different types, but this is a simple case. So note that the right hand side is a number. The right hand side is a number. The right hand side is a number. If the right hand side is a number, you can do it directly. Second example is 2x minus 5 is greater than or equals to 3. So for greater than x, if x is greater than a, we wrote x is less than minus a, or x is greater than a. If it is greater than or equals to, just write equal sign with the answer. So as it is greater than, so write two inequalities or in between. So either we have here it was x, now it is 2x minus 5. Here 2x minus 5 is less than or equals to minus 3, or 2x minus 5 is greater than or equals to minus 3. The simple case number is minus 3 and 3. It is greater than sign. We choose the left and the right. So 2x is less than 2 and x is less than 1. Less than or equals to 1 is the first answer. And the second, 2x is greater than or equals to minus 3 plus 5. 2x is greater than or is greater than, sorry, 1 is greater than, it was greater than 3. It was greater than 3. 3 plus 5 is 8 and x is greater than or equals to 8 over 4. So the answer for this question, the solution is either you take numbers less than 1 or x is greater than or equals to 4. So this is how you can solve the inequality with the modulus inequality with greater than sign in between. Yes, the answer. This was type 1 or the case 1 of the inequality. The second case is the second case of the inequality. Type 2. So in type 2, I'll solve an inequality when both sides include modulus function. In the previous case, the right hand side was a number, but here we have modulus function. on the left hand side and a modulus function on the right hand side. So we have modulus on both ends. So to solve this inequality, there are two methods. So what is method one? Two x minus 1 whole square. So the method one is that squaring both sides. Method one is squaring both sides. 2x minus 1 whole square is greater than 3 minus x whole square. 4x squared minus 4x plus 1 is greater than 9 minus 6x plus x square. So 3x squared plus 2x minus 8 is greater than 0. So recall, this is a special inequality. This is a quadratic inequality. And we solve the quadratic inequality by using uh, the graph, or there's a graphical method for the quadratic inequality. So what is the procedure for solving this quadratic inequality? First, we find the critical points. 3x squared plus 2x minus 8 equate that thing to 0. Then find the two values for 6x minus 4x midterm break method. And 3 is common, x is common, x plus 2 minus 4 is common, x plus 2. This is simple quadratic inequality of AS syllabus. So equals to 0, then it is x plus 2, and then 3x minus 4 is equals to 0, x is equals to minus 2, and x equals to 4 over 3. So after finding these critical points, what we do, we draw the graph, and by taking minus 2 here and 4 over 3 on the right hand side, we draw the parabola, because this is plus, and then as it is signed the greater than there, so greater means above the x-axis, and this part is therefore more than 4 over 3, and this part is therefore less than minus 2. So the answers are x is less than. So the answers are x is, this is the answer, this is the answer, these are two answers, and there's gap in between, and so we write, so less than, x is less than minus 2, or second is x is greater than 4 over 3. So for this question, for this inequality, both sides modulus function, this is the answer, and the method is squaring both the sides. This is your method 1 for this type. So what is the method 2? For the method 2, we start the same question. 2x minus 1 greater than 3 minus x. So ignore, question is to solve. Same question. For the solution, you ignore the inequality sign, and write equal to this. I'm doing for the critical points. These values which we obtain by squaring can be obtained by using this technique. 2x minus 1 is equal to, write plus minus as we solve the equations. So 2x minus 1, 3 minus x, and 2x plus 1 is minus bracket 3 minus x. So here is 3x is equals to 4, x is equals to 4 over 3. Yes, this was there. And the second case is 2x plus 1 is equals to minus 3 plus x, and x is equals to minus 4. X is equals to minus 3 plus x, and x is equals to minus 4, sorry, 3 minus x and minus 3 minus x. There is minus sign here, sorry. This is minus 2x minus 1. So 2x minus 1 is equals to minus 3 plus x. So x is equals to minus 2, the same answer as before. But here you can't draw the parabola, you can't draw the graph because we don't have the quadratic equation. So what is the other method? So this is called the number line method. So we check after finding the critical points. The question is here in the at the top, the inequality. So we draw the number line, and this number line, on the number line, mark these 2 points in order: the negative number on the left and the greater number on the right hand side. So there are three parts. Then we'll check which part is satisfying our given inequality. So this was the question. So for this, choose a number from starting from the middle. So here it can be x equals to 0. X equals to 0 is here. So I'm checking whether x equals to 0 is true for this given inequality or not. So I can label this as 1. So put this in 1, verify in 1. So 1 implies 0. 0 minus 0 minus 1 is minus 1. 0 minus 1 is greater than 3 minus 0 minus 1 is minus 1 modulus is greater than 3. 1 is greater than 3 is obviously not true. This is incorrect. So cross it out. The answer is not here. So let us choose a number from here. More than 4 over 3, it can be x equals to 2. It can be any number. So x equals to 2, then 1 implies the same. In 1, use 2 2s are 4. It is 4 minus 1 is greater than 3 minus x. 3 minus x means 3 minus 2 because x we have taken as 2. So it is 3. It is 3 modulus is greater than 1 modulus. 3 is greater than 1. Yes, this is true. This is correct. If this is correct, tick for that. Choose a number from the extreme left. It can be x is equal to minus 3. You verify this in 1. So this procedure is very simple. Verify in 1. 1 is, if you put in 1 minus 6, so this would be minus 7 modulus is greater than 3 minus minus is plus, so this is 6. This implies 7 is greater than 6. Obviously, this is true. This is correct. So tick for this. So what are the answers then? So answer is here and the answer is here where we have the ticks. So x is less than minus 2, same as here, or x is greater than 4 over 3, same as here. So these are the two inequalities, or these are the answers to this inequality using a different, yes, the same answer, but using the answer of the same question. So simply find the critical points, simple by writing plus minus and number line, and quickly you can do this mentally, or you can write on the page for this working. So check which answer is satisfying, which region is satisfying. So this was okay, this was okay, this is your answer, this is your answer. So this was type number 2. So either method you can apply, but the special case should be taken that this method of squaring you can apply if you have the modulus on both. So method of squaring both sides uh, works only when we have modulus function on both ends. And the second method is the number line method. We find the critical points and to verify the region. Next, there's a question, and I can label this as type number 3. So this is type 3 of the question of inequality, type 3. The question is, so in this case, one side will be modulus and the other will be not a modulus but any other function. So question is, solve modulus of x minus 7 is less than or equals to 2x plus 4. This is modulus function. One side is containing the modulus function, and this is not a modulus but it's a linear function. So Important point. Don't square. Don't use the method of squaring. Don't square both the sides. Don't apply. I can write here. For this case or the type of the questions, don't use method of squaring both sides. So then what is the method? Use number line method. Use a method of verification for handling such cases. So for the number line method, but you can do simple, solution is simple. Just ignore the inequality and write equation, then write plus minus on either side, make two cases, 2x plus 4, and the other is x minus 7 minus 2x plus 4. So we have minus x is equals to 11, x is equals to minus 11, and x minus 7 is equals to minus 2x minus 4. So 3x is equals to 3, and x is equal to 1. These are the critical points. So these are the critical points, and then there's a step of check or verification. Verification for the answer. Draw the number line. Write minus 11 and 1 on the number line, and choose numbers. From here you can use x equals to 0, you can use x equals to 2, you can use x equals to minus 12 from the left, and then verifying, starting with the middle, x equals to 0, and we'll verify here in number 1. So x equals to 0, put in 1. 0 minus 7 is minus 7 modulus is less than, as it is less than or equals to, as I'm taking number in between, just write less than. We're just verifying this thing. So 0, 2 into 0 is 0, 0 plus 4 is 4, 7 is less than 4, which is obviously incorrect. So cross it out. Then x is equals to 2. This is from the right. You put this in number 1. So 1 is here. 0, 2 minus, this is 2 minus 7 is less than 2 2s are 4, 4 plus 4. So minus 5 modulus is less than 8. 5 is less than 8. Obviously, this is true. So accept this answer. And the leftmost part is x equals to minus, the number is x equals to minus 12. Again, you put this in number 1. And this verification is very simple. Just verify, and if false, reject, and if correct, accept that answer. So we accepted this answer. Now the last is minus 12, minus 7. So I'm verifying here again. Minus 19 modulus is less than minus 24 plus 4, 19, because modulus is less than minus 20. 19 is less than minus 20 is false, thing is incorrect. So reject this part. So the only tick is here, and this is your answer. So the answer is x is, as it is in the question, greater than or equals to, x is greater than or equal to 1 is the answer to this inequality. X is greater, just x is greater than 1. So only the right most is the answer. So the numbers from the middle are not satisfying the inequality, and the left part is not, the extreme left region is, the portion is not satisfying the inequality. So the answer is here. This is how you can solve the inequality of type 3 when one side is modulus, other is not. So don't square both sides. Otherwise, you'll get the wrong answer. For such questions, you may get the wrong answer. So this is all about the inequalities. My next lecture will be on the graphs of the modulus function. So please subscribe my channel and click bell icon for more videos, and press like. Thank you.